For this lesson, we're going to just do some applications of trigonometry. First things that we need to talk about, though, are rounding. And so a couple of rules and things to remember is the more you round, the less accurate things become. So as you're trying to decide how to round, you need to think about how accurate do you need to be. If you're not given rounding directions, then you need to ask, what would be the best answer for this question? And ask yourself, how accurate do I need to be? Should I be rounding to the nearest whole? Would that make more sense? Things like that. If you're in doubt at all, then you're going to want to be more accurate rather than less. So if that's the deciding factor, then so be it. If I don't give you specific rounding directions, or if you're not given specific rounding directions, then there will be more flexibility in how you're being allowed to answer. The second thing that we need to talk about is how do you tell if you're using an angle of depression or elevation? Remember that this all has to do with perspective. And so your perspective is from eye level. So wherever eye level is, there's this horizontal line that goes across. And then are you going to look up? Then that would be an angle of elevation. Or are you going to look down? That would be an angle of depression. And so the question, are you looking up or down? And remember that it's based on the horizontal line of sight. Okay, so we're going to do some practice problems. And so as we do these problems, we're going to draw some pictures to go along with it to kind of illustrate. So the first one, a flagpole, casts a shadow. So we're going to have a little flagpole here. And then the shadow. And it says the flagpole is 30 feet tall and the shadow is 50 feet long. Find the angle of elevation. So that tells me that we're looking up from somewhere, of the sun. So we have a sun, and that's what creates the shadow, of course. And the sun is shining at a particular angle, and so since we're talking about an angle of elevation, it's not going to be this angle, because that would be depression. It's not going to be this angle, because that would be depression. If we're thinking about right here, if we're looking up to the sun, that's an angle of elevation, and so that's where your angle is that we're looking for. And so it's really important that as you're examining these problems, you're thinking about, am I looking up? Am I looking down? Where is my perspective? And so obviously we're not looking from the sun. Now if we said, what's the sun's angle of depression to the ground, then that would be different than I'd be looking at from the sun's perspective. So we're just going to use a trig ratio to find this. So since I've got this angle that I'm dealing with, and the sides that I have are opposite and adjacent, then tangent would be what I'm going to use. So tangent of angle x is equal to 30 over 50. So you're going to put in your calculator the second tangent button of 3 over 5 or 30 over 50. And you get for that about 30.96. And so this doesn't tell us how to round. So we're thinking about degrees, and so we're talking about, should I round it to 31 degrees? We're talking about a difference of 0.04 degrees. That's not very much. I'm going to go with 31 degrees. Okay, the next question, a 20-foot ladder leans against a building. So I'm going to have a building. I'm having a ladder that is leaning against the building. The base of the ladder is 6 feet away from the base of the building, and the building is hopefully standing straight up. What is the angle of elevation of the ladder? So again, where am I looking at an angle? And so the angle of elevation is going to be this one. The number one mistake that I see students make is they'll call this the angle of elevation. And so you got to be careful that you're looking at this from the right perspective. So the ladder is 20 feet. I'm looking at this angle of elevation of the ladder. So that's the angle I'm looking for. So because that's the angle, I've got the side adjacent and the hypotenuse. So that's going to be cosine. So you're going to type in your calculator cosine -1 6 over 20. Okay, that's going to give us about 72.54. And so again, we're talking about less than half of a degree, and if you think about how big a degree is, that's pretty small. And so I think that it would make sense to round it to 73 degrees. However, if you're so inclined and want to leave it at 72.4, I would be flexible because I didn't tell you where to round. Okay, the next question, the blade of a ceiling fan rotates 17,280 degrees per minute. So if you think about 180 degrees is half of rotation. So in a minute, it's going multiple rotations. So it's going around and around and around and around in a minute. So we're going to take the 17,280 and I want to know how many degrees per second. So if this is for 1 minute, how could I figure out the number of seconds? So if I take my 17,280 degrees and instead of a minute, if I divide it by 60 seconds, that will give me how many degrees per second. So it comes out to 288 degrees per second. Okay, now the next question, we have a lifeboat, and so I'm going to have an ocean. And my lifeboat is sighted from a rescue helicopter directly overhead. So let's draw a lifeboat. I'm going to put a little red cross on the top. Okay, and we've got a helicopter that is directly overhead. And it says that it's sighted from the rescue helicopter directly overhead at 225 feet. So we're going to have this length is 225 feet. Then it says after rescuing 4 survivors and taking them to safety, because a helicopter can't hold that many people, the helicopter returns to the previous position. So the helicopter goes back to where it was before. But when it gets there, the boat isn't there. It has drifted. And so the helicopter is now sighting the lifeboat in the water. So if you think about from the helicopter's point of view, they have to look down to see where the lifeboat is. So now the lifeboat has drifted. And so the question is, how far has it drifted? So I need to know this distance right there. And so the tricky part about this is, where do I put the 24 degrees? So it says that it sights the lifeboat at an angle of depression. So something is looking down. So where would it be? The number one mistake is people will put the 24 right there, and that's wrong. So if you think about an angle of depression, it's the helicopter that is sighting the boat. So there's the line of sight. It's sighting the boat. It has to look down, so 24 degrees. Now remember what we know about parallel lines and a transversal. And if I have an angle and an alternate interior angle, they're congruent. And we can apply that knowledge to this picture right here, because I have a line of sight with this line across, and I have this transversal. And so this angle and this angle are congruent, and that's important because this right here is my triangle that I'm looking at. And so this is going to be my 24 degrees. And so if I'm trying to find x, the 24 is adjacent to that, and that's the opposite. So I'm going to say tangent 24 is equal to opposite over adjacent. Now another option for that is, because this is 90 degrees right here, if that one is 24 degrees, this would be 66 degrees. And so I could say tangent 66 is equal to x over 225. Both of those equations will work. One of them will be a little bit faster. And so when you find out what x is, that's how far the lifeboat has drifted. And you get 505.36 feet approximately. And so if you were to round that, you can ask, do I round it to the nearest foot? So in light of 505 feet, about a third of a foot isn't really that much. It's only about 4 inches. So I would say that probably 505 feet would be good. If we were only talking about, a couple dozen feet, then maybe 3 or 4 inches would make a bigger difference. So the last question in the notes, a camera on a tripod. So we're going to have a tripod with a camera on it. It is 5 feet tall, and it has the top of a building in its sights. So as we are looking from the camera to the top of the building, the angle of elevation is 24 degrees. So where is it looking up? So the line of sight of the camera is right there, and it's looking up to see the top of the building. So that's 24 degrees. So the tripod is 40 feet from the base of the building, and the question is how tall is the building? So if I find this length right here, to find the height of the building, I'm going to have to add on another 5 feet. So pause the video, make sure that you can do that one. So what you should do is say tangent 24 is equal to opposite over adjacent. And so 40 tangent 24. Of course, make sure you're in degrees for all of these because otherwise it won't work. You won't get the same thing. And so for this one, you get x is about equal to 17.8. And so remember to add the 5 feet. And so when you do that, you get 22.8. And so that's how tall the building is. So the question is, do I round that to 23 feet or 22.8 feet? We're only talking about 22 feet. And so in light of that, 8 or 9 inches, is kind of important, or 3 or 4 inches is kind of important. So I personally would say 22.8 feet in that smaller number. But if you said 23 feet, that would be totally understandable as well.